Okay, this is some practice from lesson 12, the summary of lesson 12. And this is really activity 3. And the best way to learn about working with these equations, working with the dilation, the scale factor, where to place the coordinates based on that dilation, is to make some problems up on your own. So get a sheet of grid paper or use Doceri and import or make the background this graph paper and draw right triangles. I'm just going to use 3 points here, the 3 vertices of the angles, connect them, and right away, so just drawing this right triangle, right away I can tell you what the slope is, and you can tell me what the slope is. It's the vertical distance, which is 1, 2, 3, 4. It's that ratio to the horizontal distance, which is 1, 2, 3, 4, 5. So what that says is that the vertical distance is 4/5 of the horizontal distance. So it's the ratio of 4 to 5. So whatever the vertical distance is, if it's on this line, if it's part of this, on this line, whatever the vertical distance is, it's going to be 4/5 of the horizontal distance. So right away you start to practice seeing what the slope is. So then just play around, place a y-axis on the grid. And right away you see that if you place the y-axis here, you see that the the horizontal distance, you have to take away this amount to get this triangle to line up with the y-axis. So you have to remove or subtract 1, 2, 3, 4, 5. So right away you start to see if this is x up here, and this is 5 units along the x-axis, so this is going to be x minus 5. So x minus 5. Well, that's the bottom half of the equation for the line. And so right away you're starting to see where that equation comes from. So you're going to slide this right triangle over here 5 units. Now what if we placed a y-axis right here? That means the horizontal distance is going to be x plus a value. You're going to add x plus 3 because you have to slide this to the right 3 units. Well, by the way, that's the same as x. It's x up here minus a negative 3. So this is 1, 2, 3, and negative 3. So it's the x value minus the x coordinate here, and that would be negative 3. So x minus a negative 3 is the same as x plus 3. So this is a nice way to practice adding and subtracting positive and negative numbers. So you slide this over 3 units. And what if we put the y-axis way over here? Well, it doesn't change. It's the same thing. As the math is all following the same pattern. So this is going to be x plus 8. This is the 5 units plus 3 more to move this point all the way over here. And by the way, once again, that's the same as x minus a negative 8. So if you take x and you subtract negative 8, that's the same as x plus 8. So that slides this over here. That's going to tell you what this this horizontal distance is, which is going to be 5 units. So x plus 8, wherever you are, is going to equal, give you this horizontal distance. Okay, so now, what if we do the same thing with the x-axis? So now we're going to figure out the vertical distance. And so if we place the x-axis right here, we have to slide this triangle down to the x-axis, and that's going to give you the vertical distance, how far this is away from the x-axis. And it is, you have to slide it down 3 units, so that's going to be y minus 3. Well, that's the upper part of the equation. So now you have y minus 3, and over here we have x minus 5. So it's the ratio of y minus 3 to x minus 5. What's that equal? It equals the slope, which is 4/5. There you have it. That is the equation. So it is through making up your own problems and practicing that you'll start to understand how to work with these problems. So this is y minus these 3 units. That gives you this vertical distance, which is equal to 4, by the way, for this problem. Well, what if we put that y-axis, or I'm sorry, that x-axis right here? Well, now we're going to have to add to the y value. So this is going to be y plus 1. So this is going to slide this up 1 unit. Well, by the way, that is the same as y minus a negative 1. This is at negative 1 along the y-axis. So y minus a negative 1 is the same as y plus 1. Once again, good practice for adding positive and negative numbers. And what if we put the x-axis way up here? Well, that's going to be the same as y plus 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Y plus 6. I thought it was y plus 7. Anyway, y plus 6. So by the way, that's the same as y minus a negative 6. So if this is at negative 6, then that's the same as y plus a positive 6. So it slides this up. And so you have different equations that you've put together just by looking at this through examination and starting to gain an understanding of how to deal with these. All right, so let's move this back, and let's move this all the way over here. So now we're going to work with this triangle placed in this spot. So you would write down what the coordinates of this spot are, and you could call this x, y. Eventually you're going to write down the coordinates right here. And the horizontal distance is this x minus 5 right here, and the vertical distance is y minus 3. And if you add some coordinates, some numbers to this, that's going to give you 5 units along the horizontal distance and 4 units along the vertical distance. And I moved this way over here so I could dilate this using a scale factor as large as possible. So if I use a scale factor of 5, it's going to get all the way out to this point. And this is going to go all the way up here. And it's really, I think it stays right on the page. I think it's right here. You'd have to extend this out. You're going to figure out what that point is if you use a scale factor of 5 anyway. But you can challenge yourself. Use a scale factor of 4.5 for this problem. So you're going to figure out, you're going to decide what scale factor you want to use. You're going to dilate this triangle. You're going to figure out what the coordinates are, because you're going to realize that whatever the scale factor is, I have to multiply that times x minus 5, and then I have to add that 5 back. Then I have to multiply that same factor by y minus 3, and then I have to add that 3 back to get to this coordinate up here. So try a scale factor of 4.5. 4.5 would be right here, and you can actually just graph it to check. Try a scale factor of 3 3/4. Challenge yourself. Work with some fractions. Work with a friend. Try to do several of these problems. By the time you're done, you will know how these equations work, how the dilations work, how the scale factors work, and how you figure out the placement of the coordinates, and how you use the equations check that placement. Because then you plug the x coordinate and the y coordinate, whatever you determine, back into the equation, and if it equals, in this case, 4/5, then that point lands on this line as part of this line. So that's it. Do 2, 3, 4 of these problems, and you'll start to understand it.